The Environmental Medicine and Human Engineering divisions of the 6570th Aerospace Medical Research Laboratory are studying the use of rhesus monkeys to penetrate hostile areas, then seek out and destroy selected targets within those areas. This is Paisley Print Task 1. The AMRL study is part of an overall Air Force avionics laboratory program to define a series of penetration aids for use as offensive countermeasures. Actually, this report begins in the laboratory. So let's go back and take a look at the details of this representative example of biotechnology applications to offensive countermeasures. The rhesus monkey was chosen for this task because of his high level of intelligence, enabling great flexibility in performing a wide variety of assigned tasks. Another factor was his broad native habitat, which spreads throughout the entirety of southern Eurasia and northern Africa. While other animals have been trained as penetration aids in the past, until now they have been relatively unsuccessful. This is perhaps due to the selection of an inappropriate species, along with the rapid advancement in the state-of-the-art of conventional systems. Following months of gentling and leash training, lever pulling for food pellets, and final shaping with a radio-controlled stimulator, the subject was deemed ready for the field trials. The subject's dress includes a pocketed vest containing a telemetry package. Miniature electrodes are affixed to the vest and located to touch the animal on the lower abdomen on either side of the umbilicus. A mild electrical stimulation through these electrodes will differentially reinforce the monkey and guide him within visual range of a simulated target. The animal's backpack contains the receiver portion of the radio control system, the battery, receiver, stimulator, on-off control, and the antenna. One lever on the model airplane transmitter delivers the stimulation signals to the vest electrodes. As the lever is depressed, the strength of the stimulation increases. To ensure proper contact of the electrodes on the subject's body, excess hair is removed from the areas of contact. Masks worn by the medical team are to protect the animals from communicable diseases. This particular system being worn by the subject weighs 412 grams and has an operating distance in excess of 1,000 meters. The animal weighs 3 kilograms and could reasonably be expected to carry a load equal to 1/3 of his body weight without the least bit of difficulty. By increasing the size of the animal up to 12 kilograms, loads of 4 kilograms could be carried into the target area depending on mission requirements. A receiver weighing 4 kilograms, for example, could have an operating distance of more than 20 miles. Direct line-of-sight guidance is used in this test. When deployed operationally, however, a two-transmitter system of vectoring or triangulation would be used. When the animal strays off course or loses his bearings, the test director provides mid-course corrections by activating the lever on the transmitter. Once the rhesus is in the immediate target area and is able to recognize and visually acquire the target through his own senses, he is released from the remote-controlled guidance system. Realizing he's entered the wrong objective, he searches further. This time, he knows he's not mistaken when he sees the familiar response lever, which he pulls. Mission complete. Scratch one threat. Paisley Print Task 1 represents a form of behavior or the capability of an animal to perform specific tasks at selected target locations. This biotechnology application of offensive countermeasures provides the Air Force with an additional capability to penetrate hostile areas not accessible to man. It's a highly feasible method of gathering visual information in and around hostile areas and of the targets in those areas. This could be accomplished by mounting a camera on the harness of the animal. It's also a conceivable method of delivering explosives, beacons, and various sorts of sensors to the heart of enemy operational positions.